Zvuk už jde? Halo, halo.
All right, so seems we're ready. So welcome. Not yet?
I think it's time to start.
It's already time to start. So hello again. Welcome to our Backendisti meetup. It's already 14th meetup. So I'm glad that you arrived. Today we'll have again 3 presentations from people from the first one will be from outreach, and then we'll have 2 other ones. At the end, we'll also have a networking session as usual, which is hosted by outreach. So thanks a lot for that. And today we also have an open terrace. So after the presentations, you're welcome to join us at the terrace. Have a walk there, have a networking, and also look outside because there's also a nice view. And of course, during the presentations, you can ask your questions at Slido. So feel free to join at slido.com. If you enter the hashtag Backendisti14, you'll be able to ask the questions, and you can also vote for questions from other people. So please do that because we'll select only a couple of those because we'll have a limited time.
Yeah, and don't forget to join our Facebook community, Backendisti Comunita, and you can ask questions every time you want.
All right, so I hope you'll enjoy today's sessions, and I would like to welcome our first speaker.
Do you hear me? Cool. So welcome to my presentation about testing story in the times of monolith decomposition. It's my first presentation after COVID and being very introverted, so I will try to make it. I will start to say something about me. I'm in the industry since 2005, spent like first 10 years in Microsoft shop doing software in C# mostly, then I switched for 3 years to doing agile coaching, and like since last 6 years I do again IC roles, doing a lot of stuff around JavaScript, TypeScript, AWS, and at Outreach I'm doing Golang and Kubernetes as well. So that's like thing that I learned in the last year. So I will talk a little bit about Outreach. Outreach is a company full of software developers. We don't have much QAs. So like the presentation is about like how you should test your application in the times when you split it from the one big chunk of code like called monolith to smaller services. And in that situation, you need to do like different approaches. And I would like to talk about Outreach. We do software for sales engagement. Looks like this. It's React application on the front end and a Ruby backend. Something kind of typical. And in the time when we had monolith, we still have it. We are in the process of decomposing it. Like the setup looked very simple. We had like just one monorepo with a React application, backend application, and it all gets deployed to Kubernetes cluster. If you look at it from the process perspective, you have one repo, one deploy CI/CD deployment pipeline, and you can very easily deploy your application to tested application, and you can see like the stage. You don't have like disconnected parts of your application. So typically when the monolith grows, it can be very complicated, or it can take ages to build it, test it, and so on. But from the process perspective, it's simple. How we deploy our application, Outreach has like staging environment when there is like Kubernetes cluster and 3 customers environments, or environment stages. First is for internal customers, and then we have like a lot of Kubernetes clusters for big customers. if you test a monolith application, you can look at it from the perspective of test automation pyramid. You have single application, you have bunch of unit tests, you can have some integration tests and end-to-end tests. The question is how you should do it in the situation when you split it to smaller pieces, because then if you then you have like multiple parallelly deployed applications that deploy like independently on each other. So if you have monolith, it's like a simple situation. If you you have monolith where you have application the old way written. It's typically like simple architecture, and then you have like the target state that you imagine in front of you. We have like GraphQL layer and bunch of services talking to each other through gRPC and databases and Kafka queues to synchronize data, and there is like bunch of internal calls in the Kubernetes cluster. But the problem is when the situation of the transition from the monolith to the smaller services, since you have for the long time a lot of complexity connected with having both monolith and bunch of decomposed services. Yeah, and what gets much more complicated is like deployment, because you had before just one process of deployment, but when you split it to services, you get independently deployable applications, which can be like deployed to like single Kubernetes cluster, but independently. So here on this picture, you can see that we deploy to staging right after you merge your PR in GitHub. And then we have some time-based promotion of application. It can be UI, it can be like this aggregation GraphQL layer or the services, but they deploy, like we have it configured time-based, so they deploy every day to production environment. And you can see like the UI communicates with GraphQL, GraphQL connects services, and services are connected together, and these things need to work together. If you deploy them separately and you don't do it cleverly, you have a problem, typically. So I joined Outreach as like a team member of Quality Frameworks team, which should provide some tooling for others to write their tests and to improve like quality of the product. So first thing what we did, in the early stages of monolith decomposition, we created like a UI end-to-end test framework, which gave some overview over the state of the staging environment before it gets, before the software gets to the next stage, like to customers. This we configured also as a promotion gate. So that means that, for example, because we were testing through the UI for various reasons, the UI cannot promote to the like production environment without these tests to be green. And it also gave quite good feedback about the staging like health to other teams who are responsible for other parts of the solution. Yeah, how we did it, like standard technologies, Cypress, Puppeteer. Our application has like some specialties like Chrome plugins, software as a service integration, and this UI-based end-to-end tests were allowed us to test these use cases as well, which provide some value to the company, since you don't have to have QAs to test this like on daily basis. And for example, you can, using Puppeteer, test even the Chrome plugins integrated, your Chrome plugin that is integrated, for example, with Gmail through the DOM. So these tests, what are they doing? They have some like gist of the test, like to test some part of the UI, but you need to have data. So we see data through GraphQL layer, then we run the gist of the test through UI, and once a day we clean up the data. How it's performant, like we just created frameworks, teams wrote their tests typically themselves. It's quite surprisingly quite fast in our case. So we were able to finish like the fast suite in 5 minutes with 17 jobs, typically 1 job per team. And we had as well some slower suite, which runs under 20 minutes, 16 jobs. This is mostly like these integration parts that can break. And it's are quite flaky. On the other hand, what other way you have to test like that your plugin works? Because if Google decides to change their DOM in Gmail, it will just stop working, and you need to do like new version of the plugin. So it still provides value that you know that it's at least working on the high level. Yeah, and in the times of monolith decomposition, there are situations when you roll out part of the decomposed services. Typically, when you extract some functionality from the monolith to some service, you first like read master from the service, then you write master from the service, and so on, so that you can like extract it. And in this situation, these tests allowed us. We configured these end-to-end UI end-to-end tests to test these scenarios. And what allowed us to do that is like launch darkly, which we use for a feature flags. And we configure it as well for this like architecture rollouts. And we were able to configure like one workflow of this end-to-end test to run in like future state of architecture, which gave us the teams that are doing this feedback about how does it work on a high level. Like it's more like smoke test, but it was valuable. So yeah, so that was the first thing. On the early stages of monolith decomposition, we provided this UI end-to-end tests. That's one part. The second part that was done actually by other team, but we support that as well, is service end-to-end test framework, which provides a way when you have this decomposed service to test your application on the PR level. So you have like PR branch, you have some change of your code, and what is being done, you'd like create new ad hoc kind cluster, deploy like the monolith typically, and dependencies of your service or application, and then then deploy your own service in that PR branch and run some end-to-end tests to give you feedback that this change of code will not break anything. So that's kind of how the testing pyramid changes in the situation. When you start decomposing, you don't have one test pyramid, but similarly as with processes of CI/CD, you have multiple test pyramids. So the end-to-end testing on the pyramid of decomposed services, we understood this way. So how does this process works? On the PR level, it creates like kind cluster in Linux VM, which is like Kubernetes in Docker. And then it restores snapshots. I will be talking briefly about it. And then deploy your application dependencies, and then you run the tests. The performance of this is it's like that 95% of time the application or this like end-to-end test run spends on this first 3 stages, and the test run is very fast, but it takes like 30-40 minutes. We speed it up by creating daily Kubernetes or a Velero snapshot of your application dependencies, typically the monolith and the mostly used applications or decomposed services, so that you can just restore that Velero snapshot and then deploy additional applications. It speeded up quite significantly, but currently it's about 30 to 40 minutes. Yeah, we run it on Circle CI in Linux VM when we set up, create this cluster. Yeah, if you run end-to-end test in this mode, there are two ways how you can run them. You can run them out of the cluster. That's also like very suitable for dev machines and so on. When you just because this ad hoc cluster that we are using on the PR branches can be used as well for local development of your service. So you just spin up this cluster with this snapshot, deploy your application there, and you can run end-to-end test against it, which you have in your repository in source code next to the service code. One way how you can run this test, this is like kind of historical. You need to expose the API from the Kubernetes cluster somehow. So we have like localizer service for that written at Outreach, and that just provides like exposes the endpoints from the cluster or services from the cluster, and then we have as well some way how you can like create the config maps that you have in your Kubernetes YAML file locally, so you can run the test from your computer, attach debugger in IDE, and it just works like this. But there was like not good experience with this since it's kind of flaky, especially on the Mac OS, playing with like port forwarding and like DNS resolution using host file and so on. It just seems problematic. So we have as well the new approach, how you can run the test inside of the cluster. In that situation, you just we use DevSpace for that, which is tool to replace your application pod with some dev pod, where you can build your application, start it, and as well start their end-to-end tests, so that, for example, all this like config maps and everything is there out of the box, so the tests are much easier to set up and run. The overall experience with this service end-to-end testing, it's like problematic, I would say. It takes a long time. Teams need to do quite a lot of diagnosis because you deploy there your application dependencies, and with especially in the times when you do this monolith decomposition with all this data synchronization and so on, it can go wrong a million ways. So it provides some value, but it's flaky and questionable is the additional value. So what we want to try from now is to focus more on the middle layer of the test pyramid, like integration testing, which is in our company. We have just unit test and end-to-end test, and we are missing the middle layer. So like somehow simply test your application code, like the endpoints, with like spin up Docker image of your database or Redis or whatever you use. Another thing that we want to play with is like contract testing, so that when you have inside of your cluster like provider of some API and the consumer, you can verify both sides using tool like Pact. So you can verify if you provide some service that all your clients will work after this change that you just introduced, and vice versa. It seems interesting, but might be some challenges in introducing it. So if anybody of you have any experience with that, I would like to hear it after the presentation. And that's one thing that we are trying, like solve the middle part of the pyramid. And the other thing that we are trying is like still for this end-to-end testing, because we are also like hitting limits of what you can run on your developer machine, since we have like more than 150 pods in our clusters for some application. So it's not possible in Docker spin up so many pods. So we are thinking about having them pre-created, these dev containers, using the Love technology, and so that you can just say, hey, give me the latest Kubernetes dev environment, and I would just want to run test there, for example. So yeah, something like build something like that. Yeah. So last thing I want to say is when you start decomposing your service, my experience is that in companies there are like two types of people. One type of people, like typically QA, very focused on the monolith, like as a big bench of code that you want to test together and then release together. And then you have there another part, another people who just think in the completely microservice, independent services that shouldn't be tested end to end and deployed, tested independently, and so on. So it's sometimes hard to connect when you provide framework these two mindsets together. So our approach was like that's why we built these two things. One, like the service end-to-end testing feels like more for the people who are on the like microservice mindset, and UI end-to-end test framework for the monolith like mindset. And over time, I think that the UI end-to-end test will be a little bit less and less important, and the service end-to-end test or any like contract testing might be in the future getting more and more important, since you just want to deploy your application independently. So that's it. Thank you. If you have any questions, feel free to ask me.
Yeah, now it works, all right. So thanks for the presentation. We have some questions on Slido, so I'll read it. There's only one. How do you clean test data in production?
Our main goal is to test like the staging environment before it gets to production. But we have script that runs daily, I think on all environments, including production. And we have some naming guideline in our tests, and we clean up data that are older, like test data that are older than 2 days. So for example, if you see like test failure, you can still see the test data there and play with it, but the older data are not just piling up and slowing down the test cases.
All right, so if anyone has another question, please ask on Slido. There's only one more for now. Maybe the another one will appear. So why did you start with UI tests in the decomposition process?
Because we didn't have any like safety net, so it felt like good way to have at least like smoke test of environment when there is like lot architecture changes being done. It just felt like a good idea. In that time, we didn't have any better idea.
Makes sense. All right, so it really seems that there are no more questions. So unless anybody is interested in asking by themselves, I can pass over the microphone if you're interested in doing that. All right, doesn't seem so. So thanks again for the presentation. And now we'll make a really short break, like let's say 10 minutes. So at 5:10, we will start with, or sorry, is it already 7:10, right? We will start with another presentation, and we have Vojta over here from Digitu. Please come over so we can test the presentation. Thank you.
ty věci teda a mezi tím ti proběhla ty testy. Reprezentace
So we're gonna continue with our next presentation. There's still some free chairs in the front, so feel free to come here and sit down. The speaker doesn't bite, at least I hope so. All right, so yeah, I see still a lot of people standing in the back, but feel free to stand there, of course. But as I said, there's really some chairs in the front, so feel free to take them. And oh yes, still people are still coming. Okay, so as with the previous presentation, feel free to ask your questions during the presentation on Slido. It's Backendisti14, Backendisti14 hashtag on slido.com, and I'll read the questions after the presentation. And now over to Vojta and his talk.
Okay, can you hear me okay? Good? Perfect. Okay, welcome, and I'm really glad that a lot of you decided to join this session. And my role here is to tell you a little bit about Digi2, what we do, and why is change the only constant that we do pretty much every day. First things first, a little bit about me. My name is Vojta Eschner, and I'm with Digi2 for about 2 years now. I've been in IT for a lot of years. I don't want to count how many because it's one more year every year. But I'm just a nerd who loves IT and video games, and I love building Lego. But about Digi2, have you heard about Digi2 before this talk? Anyone? Yes, no. One, okay, perfect. So our mission and what we do, we try to digitize accounting with the power of AI and automation. That's in a nutshell. So pretty much if you have invoice as a PDF, we can read it, we can classify the data and send it to some accounting system. That's it. That's what we do. Hopefully, our mission will succeed, and we'll have zero waste accounting. So accountants will not waste their time filling out data manually, and they'll be able to spend some more quality time with their kids or doing anything more meaningful. So changes. I didn't want this talk to be just what we do, so it's just an FYI, we do it like this and that's it. I wanted to give you some ideas that might help you. Of course, you might already use some tools or some things that I'm going to be talking about, but hopefully we'll be able to join after all the talks, and you'll tell me that we need to change again because there's a much more cool tool we can use. So I'm really looking forward to that. But the change of tools, what we've been doing in the last year and a half. So we've been using GitLab for quite some time, but we've decided to move to GitHub, and the reason for this was kind of economical, because our AI team, which is a self-functioning unit, is using a lot of repositories already in GitHub, so it just made sense to use only one platform for that. So of course the change was, it made sense at the time, and it still does right now. We've been able to unify our pipelines, so the deployment processes were much smoother after this changed, and we could use some of the tools that GitHub is providing out of the box. Of course, I understand that it's also available in GitLab, but some of them are just much. There we go. So one of that is Dependabot. It really saves a lot of time for us. It's a tool that checks your dependencies, whatever you like. So you don't have to worry about npm packages, yarn packages, whatever package manager, composer, JSON, whatever language you run, you just add a little file. There's an example from our monorepo on the right, and it can run every couple of hours even, or even a couple of days, up to you. and it really saves a lot of time. We used to run it every day, which created kind of a PR nightmare for us, because it created 10 new pull requests every day, because it never stops. It's a never-ending process. So we decided, no, we don't want to do that. We created some more rules, so it doesn't check every minor version, but it just updates every 7 days, and we are much more happy with that. Another thing that we started to use, thanks to the transfer to GitHub, was GitHub Actions, because we could automate everything. In GitLab, I understand again that you can automate everything, but with the dependable that you've seen before, it just creates a new pull request. It runs through all of our tests, and if it's green, I can just merge it right on. It breaks in like 1 in 100 cases, of course, but it really saves a lot of headaches a lot of times doing everything manually. So we've automated everything from the PRs, from deploys to our pre-productions, and we are just using the standard releases in GitHub for our production release. So we get a really nice release notes for every release that we do, so we can share it with pretty much anyone. Another thing that we are trying to consolidate is our monitoring and debugging tools. We've been using Grafana for logging, Sentry for some real-time monitoring, and we've been using New Relic for APM and performance monitoring of our cluster and everything that's run within that. We've decided to make a change to Elastic IO for everything that concerns the logging and the APM, because we've already been using Elasticsearch and Elastic IO in our monorepo, in our solution. So it just made sense to move everything to that one, and use Kibana, and just see every log what is happening there. And it actually really helped us a lot. I hope it's visible. Yeah. So. What this really helped us do is a better understanding what really goes on in our app, because it's not just a call to an API or just a fetch or select in the database. It takes so much more effort to just return some data to the client. So what you see here is a breakdown of one of the API calls that, of course, also is available in New Relic, but for some reason, Elastic does it better for us. It really it shows what was the tables, Redis connection, where it hanged in Elastic, so we can really pinpoint the performance points and where we need to like take actions immediately. So we are not spending money on resources we don't have, because we are making 10 more database queries that we didn't have to do, because we already did in the first place. As you can see here, here I'm selecting something from table E. This is not the real table names. We are not masochists. I just changed it for this presentation, so it makes sense. So that really helped us, and we are actually seeing real performance boosts on our pre-production and production. So it really helped us a lot. One of the struggles that we also had, and was also fixed by moving to GitHub, was the change of our Git flow. This was before, so I think that you've seen it somewhere. I think I saw it in the last session of Backendisti last month from one of the talks, and this was handed to us as a company standard. This is how it should be done. That's how it is, and it was a nightmare. We ended up with like 50 or 60 open PRs, and they were unmergeable because of the release branches. Dev and main was out of sync all the time. Nightmare. It didn't work, and what it created, it was blocking our environment. So we just merged something into our pre-production environment. It was just wrong. It didn't work. So it's blocked. We have to fix it first. Everything stopped. It was a nightmare. So what we did, we just scratched that, and we tried to implement trunk-based development. So we've got one main branch and everything, and that's it. That's the only stable branch that we have is the main branch. And we created, well, everything is coming from the main, and we create every PR, and every PR is testable within a preview app. So if you have the possibility, I really urge you to try to implement preview apps if you are not doing it within your line of work, because it can save a lot of time, because it brings the feedback from testing, from business product, so much closer to us developers. Because I'm getting feedback in an environment where it can be broken, and I'm not blocking anyone. So within our preview apps, we have the fully functioning environment. So we've got separate database, separate Elastic, separate Redis, separate Rabbit, and everything. The tester can go there and test anything. Of course, it can be broken there as well, but we're not blocking anyone. So that really helped us a lot. Now, this is a change that I hope will resonate with you a little more, because it's something that I think is not seen nowadays. Because long story short, a little bit history of Digi2. So we've got a front-end React app, we've got an API, and within that API, we've got a classic REST API for our integrators. So you don't have to use the front-end React app to use our services. You can use REST for that, and you don't have to see the UI ever. In the history, we used GraphQL only to communicate with the front end of the app to the back end, and it worked, of course, but it pretty much well, we didn't get any work done properly, because we had to focus on both strategies, so both GraphQL and REST, and it just didn't make sense for us. So we decided to abandon GraphQL. And don't get me wrong, I like GraphQL. I don't hate it. I like it. It's really great. However, in our use case, it was either, well, not the perfect tool to use, or we were just implementing it wrong. It's, I don't know. But after this change, because we wanted our front end, the React app, to be in the same category, same level as our integrator. So they are using the same API, which is always tested. It's always 100% clear what it does, and it doesn't break. If it breaks, nothing works. So we get notification immediately. It brought some fruit, but it, as I said, it could have been the result that we are just implementing it wrong, because all of the resolve fields and such. But what you see on the right, it's one of the screens from our app, and it's just a list of invoices. And it could take a long time to load. Like the average was 3.5 seconds, so it was like, will it ever load? Skeletons everywhere, just no invoices, no invoices. Just give me the invoices. With the change to REST, we managed to decrease the load speed of this page by quite a lot. So now it's not instant, but we are getting close to that. So that really helped. And one side note, the biggest satisfaction I had from this change, because of course the front-end team almost killed the back-end team when he said, okay, we are dropping GraphQL support like now, and we are just moving to REST. So that was not a pleasant conversation with the front-end team, because of course they love GraphQL as much as the next guy. But the best satisfaction I had from the front-end team was the feedback on one of the other pages where also we switched from GraphQL to REST, where a front-end developer came to me and he said, so I went to this page and I wanted to implement the loading skeletons. I don't need to. It's that fast. We don't need loading. It's just loaded. We don't need loading. So that was really something that really helped. Of course, with the switch from GraphQL to REST, we are dropping the biggest thing from GraphQL, and that's that you only get the data you need. So how to do it in REST? Well, there are a couple of hints how we are doing it. So we are using class transformers to expose only those fields what we have. So we got DTO classes which only have fields that are returned, and everything which is not directly exposed by a decorator, we just drop on the output, so it never reaches the client. And of course, there are how to deal with the resolve fields, because it's a really cool feature of GraphQL to just fetch anything anywhere. So what we are doing, we've got include and exclude fields in our API as query parameters, which are predefined. So we just can enhance our data a little bit. I know it's not GraphQL, and we don't want it to be GraphQL, but we really want to have a strong core API which our app can use and our integrators can use. When Digitu started, it was 2.5 years ago, 3 years ago, I think. And of course, some of the architectural decisions, namely in the database schema, were good enough at that point. And I still see them as, yes, in that time, it was good enough. Yeah, let's use JSON-B fields everywhere. It's cool, that's perfect. We don't have to write columns. We don't have to write anything. That's perfect. Yeah, perfect. And of course, 2.5 years later, someone came to the code and say, why? What can I do with that? Because of course there is gonna be issues. And one of the issues, of course, is performance. What if you want to search the JSON-B field? We're using Postgres, so it seems that Postgres 16 is gonna have a little bit better searching, better everything within the JSON. So hopefully it will help a little bit. But still, this is all good until your clients define the JSON. And unfortunately, one of the tables had a really simple JSON of just option and value. So key, value, key, value, key, value. Unfortunately, it was a product catalog about 500,000 items, maybe more. And it kind of took a couple of megabytes in that column. And I've got a call from our tech support, and he says, hey, I've got a client on the call, and the Digitu page is not loading. It's just white screen. And he says that his computer is melting through the table. What should I do? So the load was unbearable for the front end, for anything. It was just the browser could not comprehend that much data, because it was the whole catalog from an e-commerce system. So what we had to do, we had to move as soon as possible from the JSON-B field for this specific column to a standard database entities. So we have to split it up, and of course that helped with the load, because we were not loading everything, the hundreds of thousands of items, but only the thing that the user needed. So that really helped. We could fully coverage it with end-to-end tests, so it never happened again. And of course we tried to implement it as well as nice as possible, so to have some gradual change. So every time we are making such a migration, and we are doing this right now, we do it gradually. So the code that is new is now on the production, but it's not used. It's just waiting for front end or anyone to catch up. But it's already prepared for the next one. Now, I know this is Backendisti, so sorry about that, but I really wanted to share one thing that we've been changing, and that actually is really connected to backend. And that's Next.js server actions, because that's pretty cool, because it's a node server, it's a node environment where you can do anything from database call to calling an API or anything. So pretty much every site within this, you can just prepare on the server and just return it to the client. So without any static generations and without any prefetching of data from some other source. You just pass the data you want. You can add your logic to it. So if you want to redirect the user somewhere else, you can without even hitting the client. So that's pretty cool within the Next.js. And one other thing within the newest version is form actions. So actually, you don't have to within the form action. Usually on the front end, there is some library that handles the descending, the validation, and such. And still, you can still use that. But within the form action, you can add the Next.js server action, which is the just a function that calls some API. It can revalidate the cache, and it can like immediately update the UI without any other work using new hooks in React. Sorry for the front-end window at Backendisti, and that's it. Thank you very much.
All right. So thank you, Vojta, for the presentation. I've been reading through the comments through your talk, and it's already a flame war over there. So brace yourself. I'm gonna read a couple of these. So let's start with the easy ones. Did you consider using Sentry also for APM?
We did, and we decided we're gonna use Elastic, and that's it. Yeah.
All right. No more context.
Yeah, no. We also maybe abandon Sentry as well, so we can just have because right now we have a lot of tools, as you saw. We've got Grafana, a New Relic, now Elastico.io because we haven't fully switched to it yet. We've got what else is there? Sentry. Well, it's a mess. So I would like to use one tool for everything. Not sure one tool can handle everything, but hopefully will do.
So basically, you're looking for some consolidation of the tools. Yeah. Okay. Makes sense. All right. Next question. Which technology do you use for preview apps? Vercel? By the way, GitLab has review apps.
That's perfect. No, I didn't say that, but I have nothing against GitLab. I have nothing against GitHub. I like both of them. As I mentioned, it was just it made sense for us to migrate everything to GitHub. For preview apps, we are using our own Kubernetes cluster, which is just deployed to our dev cluster. So it's just a bunch of Helm charts and Terraform commands.
Okay. And now
let's go.
If you moved from GraphQL to REST because of performance, I would fire anyone responsible for this decision.
Yeah. As I mentioned, there were just two solutions. Either GraphQL was not our use case, or which is more relevant, we are just implementing it wrong. So we just didn't make just such a good job. But we decided to make this change so we don't have to cover both technologies because, of course, the whatever is lying underneath GraphQL and the rest is pretty much probably the same. But you have to support both DTOs for the rest, the input types objects for GraphQL, and that can take some time to put them to sync. Of course, there are tools for that, but if I went to, let's say, Raiffeisen Bank or any other bank and say, hey, we've got the cool GraphQL API, let's go, let's talk. They're not gonna talk to me if I say we've got GraphQL. They have no idea what it is.
Okay, so it was mostly for end user-facing APIs instead of your front-end.
Yeah. Okay. We wanted our front-end to be on the same level as our integrators. So they use the same API. So we are just writing one single API for everything, and it's a 100% bulletproof solution.
Okay, thank you. When you selected Elastic.co, have you considered other options like ClickHouse?
No, because we're using Elasticsearch within our solution. So we already had the whole environment prepared, but New Relic was a solution used by a former DevOps engineer who really likes the product. But again, for us, economically it makes sense to just move everything to one platform, since we are paying for both. Why pay for both?
Okay, have you tried Parsec as alternative to Grafana?
Parsec. I haven't heard about Parsec.
Okay, so that explains a lot. Me neither, to be honest. Well, you don't use feature branches. How do you release features to production?
Okay, so the flow goes like that. We've got main, and any feature that is created goes from main. Of course, it has to always be rebased to the latest main if some other stuff goes before the merge. The preview app is then tested by testing. We've got automated testing, we've got Cypress tests, we've got manual testing. If everything is okay, it's merged to main. And every now and then we say, hey, let's go for a release. And whatever is in main, we just release.
Okay, so I think there might be a little bit of confusion in the question, because probably you meant that you're not using long-lived feature branches that are then merged to dev or something, rather than not using like feature branches at all, meaning like you basically create a branch straight out of main, which is short-lived, and then you merge it back to main, right? Okay.
Yes, exactly like that. And we use tags, Git tags for pushing stuff to pre-production and then to production.
Okay. So hope that clarified the question a bit. What is the structure of the main application? Is it monolithic or more service-oriented?
Currently, it's a monorepo, so we're using Nest.js for the backend at this point, which is a modularized architecture. We're using some sort of a domain architecture underneath the hood, but right now we're deploying both front end and back end, so it's similar to what my colleague had in the previous application before it was a monorepo. So it's pushed as one to either the preview apps or the stable environments.
Yeah, I think the question was a bit different, but doesn't matter
No.
Is it? It was the question: is monolithic or more service oriented?
It's
so
monolithic.
Yeah. So do you retest your apps after updating versions via Dependabot?
Yes, so before every release to production or even to on the pre-production, we are testing it manually. We've got a list of things that we always have to manually do because we're still a little bit struggling with our Cypress testing, which is not stable 100%, but we are getting there. So we know that if something is broken, we can take a look at it.
What logging and metrics collection solutions do you use?
What logging?
What logging and metrics collection solution do you use?
Okay, so for the logging, we're using Morgan for the REST API, and I think Winston for other application logs. These are standardized to the ECS format, so it's feeded directly to Elasticsearch, to Kibana, and parsed, so I can make some dashboards and see what's what. And we're using Prometheus for the hardware on the cluster.
Okay, so now we have another comment. I think it's a good question or remark for the networking session, because it says if you do rebases, like you say, you need to educate yourself. So it's a bit mean, but on the other hand, like feel free to connect and at the networking session, and definitely there'll be a space to discuss.
Sure.
And okay, so we have a couple more questions. So maybe I'll ask the audience to also vote for the questions, because we won't be able to go through them all. So I'll just pick another one. Which is, do you use any solution for tracing?
Tracing what?
Probably code, like debugging or...
Debugging. Yes, we are using SonarQube.
Ah, okay. All right, so the audience has voted. Have you considered using Azure DevOps instead of GitHub when moving out of GitLab?
Yes, we did, and we are actually using Azure DevOps for one specific task, which handles database migrations. But we did not have the skill on the team to fully migrate our pipelines, everything to Azure DevOps. That's why we didn't do it. We went with GitHub Actions at the end.
Okay, why was your GraphQL so slow? Did you consider using batching, data loader, which can speed up your database very significantly?
We are using data loader, and it did help a lot. So yes, but still we had big troubles. That's it. Yeah.
Okay, what technology are you using for OCR?
Well, that's more of a question for the AI team, which is like a partner team to our dev team. So I believe it's an in-house solution that they are implementing it, developing it themselves. And if it's wrong, I'm apologizing to our AI team. I'm sorry, because I really don't know. For me, it's a black box.
Okay. Do you use self-hosted Grafana or cloud solution?
Grafana, we self-host Grafana, and we use managed Elastic for well, everything else.
Okay, and one more. Do you use staging environment or just prod and preview?
We are using currently the preview apps. It's really important for us, and we've got the pre-production environment where our either testers or automation testing is ran, and it's also used by special people called the annotators, who are just going through the invoices and they are pretty much teaching the AI, our AI, what field is what. So for us, it's like it's not the same as production, but it's really, really close, so it has to be up to date and every time 100% ready.
Okay, thank you for the answer. I won't torture you anymore because these questions were like one of the most difficult I've seen so far on all meetups we had.
I knew that the change of API is gonna stir some pot here, but yeah.
Yeah. So let's save these for the networking session. We'll have plenty of beer over there, so it will be much pleasant discussion. So thanks again, Vojta.
Thank you.
And now let's have a break, and we'll reconvene at 8 sharp.
Škoda, ano, Škoda, dneska Škoda.
Tak se to hodilo zrovna po tomu.
Dneska se to hodilo dobře.
Klidně
připravit to je to, co mají oni, jo? Aha.
Takhle to nevím, ale když se dal, co měli z dokud informace, tak nevím, že bylo tam prostě
Jasně, to říkám, že jo, jo. Teorie a praxe, moje práce. Jasně. To tvoje technologie. A to je povinný. Aha, to je taky něco, to je plný. Celou teorie a praxe na spasivu. To se někdo zkoumil, si jaký byl různý. Co spočil, to bylo
Jo, tak tady je.
A než někde jinde.
Jo, a to je 2030, to je.
Ano.
Hej.
A to mají kdy? Pro válku? Proč informační projekty nemají pro válku?
To je jenom druhá věc. To je jako modál, víš?
Fakt jo.
ale to už je docela daleko.
Tak já to měl před 12 lety, dobře, jo. 13.
To nějaký pátek je firma.
Druhý svět, ty si který?
Tak, super.
Hello, hello.
Halo. Je mě slyšet? Je mě slyšet, dobré? Tak jo. To neznáš? To uvidíš. Skifry.
All right, welcome back. So we're gonna continue with our last presentation, and after this presentation, after this talk, we'll still have a networking session. So don't go home after. There'll be still plenty of beer and some place to discuss and chat about what we've been talking for this evening. And now over to Philip with his talk.
Hi. Who of you remembers this game? Yeah, I remember playing it 25 years ago at some computer camp when I was a kid. What's interesting here is that this is the binary, which is quite old, and it still runs on a new Windows system. So, yeah, this will be talk about APIs, how to evolve them, and how not to break your users that rely on you. So let me introduce myself. First of all, this is a talk I gave last Friday on PyCon.cz. So if anyone was there, so you can safely grab a beer. It's the same talk. So all the code listings will be in Python. So my name is Philip, and I help startups scale technically. So I worked for Twisto, and now I work for MediaBoard. It's the biggest Czech media monitoring company, and it has global ambitions. So I help them process the worldwide internet of news. And I have designed some APIs, I've maintained others, and also for my work I create internal tools for developers. This is very satisfactory from a job point of view, that you know your users, you know what they are doing. I like that job. So that's about me. Now about APIs. So first, what an API is. Let's ask Wikipedia. Wikipedia says that API is a way for two or more computers to communicate with each other. Yeah, this is the classical technical definition. I hear that a lot, but I think it misses a key element. Why do we write software, and who writes the software? It misses people. So my definition would be that an API, it's a tool that's mostly for people to coordinate between each other. If an API breaks, you know the pain. Who of you had recently spent some amount of time trying to upgrade a dependency? Just raise your hand. Figure out why something broke after an upgrade, trying to migrate out of a service that was shutting down and replaced by something essentially the same. Yeah, you know it, because you are using dependencies, but you're also creating. So in this talk, I will try to go through some examples and generalize from them how to maintain the APIs and how to focus on the user. Usually, this is the commercial software that gets this right. So for example, you have seen Microsoft Windows, which has a very good reputation for stability while also innovating. Office as well, Amazon Web Services, also very good record. But it's not only only the commercial software. For example, Linux, I mean the kernel, is also very stable. It doesn't break things. Sometimes it's the user space that breaks. It's also getting better. But you have also a company that has a very bad reputation for maintaining APIs. That would be Google. Google sometimes has this reputation for time-limited trial. So yeah, the division is not between open source versus proprietary, while the commercial software has more incentive to focus on the user. It's really that. It's the focus on user and valuing the user's experience and user time. It doesn't matter if you are open, closed, big, small, commercial or free. It's this mindset. How much do you value your users, and what do you want to invest in that user experience? I got the idea for this talk at another conference where I attended a presentation about Kubernetes observability and testing this observability. And the person employed in a big tech company was working on an open source component for Kubernetes, and he was talking about the metrics that the component exports. And he casually mentioned that they got a bug report that some of their metric names are not up to some standard that the other Kubernetes components have adopted. So he said, okay, yeah, we want to change this to match the standard, but we cannot do it right away because there may be some people who are already using those metrics. So we will deprecate them, and then in 2 major versions we can safely remove them. And this was the part that surprised me. Well, why it surprised me? Because yeah, you've probably encountered this deprecation cycle, that if you increase the major version, something may get deprecated, then later it can get safely removed because you're supposed to read release notes and whatnot. Yeah, exactly. For example, in the Kubernetes ecosystem, if you have worked with that, 2 major versions, that might be a year, and you usually use a Lego of those components. So this was a fairly small component. And that means that I integrate this component and I forget about it for a year, but I want to update it because I want security updates, I want new features. And then after a year, it breaks. Or at least it creates extra work for me. So yeah, it really surprised me. Why to do the last step? Why to remove those metrics? Do they hurt anyone? Yeah, there is some value in doing this change. There is value in standardization. There is value in consistent naming. But that's the value that's for the new customers, for the new users. Whereas if you're the existing user, you have already integrated the thing. If they change the name to match the better naming convention, then they create negative value for the existing users. So here the trick would be to keep those metrics, document that they are not to be depended on. That yeah, go see the other metrics. They are better named. Hide them in somewhere at the bottom of the documentation, so they are still Googleable, but new users are not annoyed by them. Yeah, so that would be this first solution or trick, how to deal with a simple thing such as rename, which may really hurt the users or at least annoy them. In Python, you have a tool for documenting this. It's deprecation warning. You have deprecation annotation in Java. Pretty much every language has something like that. So in Python, you would use warnings.warn, and if someone uses this method and has an IDE that supports it, it will get strike through. So you can keep the method there, just mark it that you are not supporting it anymore, but keep it still there. Yeah, solved, right? But this looks ugly, doesn't it? Have a lot of unused code or old code, a code that reminds you of your old mistakes. It reminds you of the time where you didn't know as much as you do now, and it's still there. You can see it. Well, tough luck. Just learn to hide it, but you don't have to remove it. It's your perfectionism, but the user cares about a different kind of perfection. The user cares about features, consistency, stability. He doesn't care about the code. He doesn't care if there is a ton of deprecated methods. If he can clearly see what's the current thing that he should use. So okay, sorry, I just got lost. I have another example. It's a library that we depend on in MediaBoard, and we recently wanted to upgrade it. They did it almost right. They wanted to rename from the camel case to the snake case, and so they created those proxy methods. Then they added this deprecation warning. And then we upgraded to the version 3.0, and poof, it started to raise an exception. They went to the length to change the implementation of this deprecation replacement to throw me an exception. They kept the old methods. They started to raise exceptions. It's something that they could have just kept there. Another example, Django. Django is a web framework in Python, a pretty large one. We love it. We use it. And they also did a similar thing. There was a class called Signal, and the constructor had an argument which was unused. It was documented as unused, and it was in the example code in the documentation that you should use it like that. But then they decided, well, it's bad to have unused parameters, right? Yeah, it is. So they created a deprecation warning, and then they just removed it. And for us, it was problematic because it was used by some libraries we depend on, which were not maintained. So I had to go and create a release for them. And all of that could be solved by just hiding this from the documentation. So I have now shown a few examples from the open source and free software, and just you may say they don't owe you anything. They are free to do whatever they want. Yes, they are. I'm talking to you how you can do better if you're catering to your users, whether open source or cloud. An example I like, it's AWS with their Boto library. AWS has a really good track record for stability. They only recently shut down the first version of their virtual machines, 17 years old, and that meant keeping the hardware, the physical servers from those 17 years ago, and spare parts for them. So it's pretty impressive. And on the software level, they have this Boto library that communicates with the AWS cloud. And they decided to do a pretty major rework of the API between the version 2 and 3. And I think that's what the rework was for the better. But it creates a problem. Again, this negative value for the people who already invested in you. They are paying you money for the cloud. So yeah, how to solve this? They did it, in my opinion, quite well. That they created a new package, but they let it coexist with the old one. So we still, in MediaBoard, we still have a code that uses Boto version 2 style API, and we are free to upgrade it at our own schedule. That's important, because they don't add new features to the old API. That's fine, because I can upgrade this part only when I'm touching the code that needs new feature. So for example, it doesn't support the Glacier storage type. in Amazon S3. So whenever I need to work with this Glacier, I'm touching my code anyway, and I'm okay with that compromise. I'm okay with rewriting to the new version of the API, but it's work on my schedule, not on Amazon's schedule. I'm not forced to rework my code to get just security updates or whatever. So this is another trick, like letting two versions of API coexist with each other. Another thing that's more in the design phase of the API. You need to minimize the API surface. API surface is something that's part of the API, but if you expose too much in the API, people will start to depend on it, and it's hard for you to change it later. So, for example, the database schema. Is it a good API? Is it an API? Yes. Yeah, for someone it may be an API. Mostly people don't think about the database schema as an API, but if a colleague from finance comes to you and asks, "Oh, hey, I need one-time report for on the financials of our customers. Can I get the read-only access to the database?" And you say, "Okay, yes, go ahead. Here's the keys." Then in no time, he will have this automated in a cron job, and every month, the business will depend on those numbers, and then you change your user table, and all hell breaks loose because now maybe you're on a vacation, and it's the start of the month, and the business doesn't have its numbers. And you are blamed because you changed the table, you broke it. Yeah, prove. And so, for example, here in this case, the database has its own tools to shield you from this. So you can create views and functions, and they can be tested, and you have a documentation that someone is depending on that. So if you change your underlying schema, you can update your view definition, and you have your test to tell you that you need to do that. So you always need to think about what people are going to use and maybe abuse. And the last thing I want to talk about today is that sometimes you will end up in a situation where you don't think this should be an API, but it becomes an API. It may be something that's a private variable, but someone finds a way to access it, something undocumented. It may be you're developing a library that's version 0.15 and gets popular, like in Python it's pandas. So there, you get into a situation where you need to support, you may decide to support an API that was not designed as an API. It's not your fault that people are using it, but it's your problem now. If you change it and enough people are depending on that, you create problem for them. So if you are valuing your user's experience, you also need to accept that there are some de facto APIs. That if a library stays at version 0 point something for a long time and gets popular, has thousands of users, then it doesn't matter it's called 0 point something. It's not supposed to break, or otherwise those people have bad user experience. The same with your code. If you don't document something, but people find a way to use it because it solves their problem better than what's documented, then yeah, if a significant number of people uses it, then yeah, it becomes an API, and you should treat it as such. So my point is that you should think about what it costs you to maintain the API versus what it costs your users if you break the API. Here there was an example with the removal of the GraphQL API, and it was a weighted decision. They know what it costed them to change their front-end code, and that's fine. But if you are removing your code just because it's cleaner, or you are removing technical debt, but you didn't actually do the exercise and didn't try to estimate what will the support really cost you, you may break the users unnecessarily. Yeah. So one thing I forgot to mention during the talk was that this also includes the internal APIs. If you have API between front end and back end, or between services, from my experience, I found that it's beneficial to maintain the API stability even for the internal APIs. Why? Because it makes a coordination problem into a technical problem. That if you develop software in a larger team, the effort is dominated by the coordination efforts. You don't spend that much time thinking about the algorithms and how to think it. You are figuring out how to integrate with others and figuring out why something broke. So if you keep your API stable, you avoid some synchronization with other teams, and instead you spend a little bit more time coding, which scales much better. So yeah, that's it for me. And just to sum it up, the tricks to do good APIs for me would be to let the users work on their own schedule. Like keep the old code, let the two versions coexist between each other. The second thing is maintain clear expectations. Define what an API is, what is not supposed to be used. Use semantic versioning. Be explicit, even for internal tools. What is an API and what you intend to support and what you don't. But if it doesn't work out as you planned, accept that now you have a problem. It's not your fault, it's your problem now. Deal with it. Thank you very much.
So thank you, Philip. We have only one question so far. So if anybody would like to ask some questions, please go to slido.com and enter Backendisti14 hashtag, and you'll be able to ask. So the question is, what is your opinion on data contracts?
Data contract, maybe. Can you explain more in detail what you mean by data contract?
So the question is from, it's actually not anonymous, it is from Vladimir. So if Vladimir is here, please raise your hand and you can probably...
Okay.
Over there, okay, I'll bring over the microphone.
Data contract is something like an agreement between a consumer and a producer of an API. So the question is only like, what do you think about that? For example, these days you can see the tools or the software as a services which or startups which are trying to like provide you this, something like a dependable, which was mentioned in the previous presentation. There is a service which is like checking your API or something like that.
Yeah.
And it is providing you the feedback that be aware with this change, you are going to break the data contract you agreed as a producer, and your consumers will be affected by this. So it is like something like it is checking automatically the changes you are doing in your code. So.
Yeah, thank you. So yeah, I think this is definitely part of an API and something you should care about. And if you have any automation that helps you with that, that's good. I remember back in the days when I was writing Java, we had similar tooling that was diffing the API and marking which changes are backward compatible and which are not. And we were definitely using that a lot. So any automation definitely helps.
All right, so that's it. There's no more questions. So thanks again to Philip. And I would like to also thank all of you for coming, but there's going to be a networking session, so feel free to have some beer. And of course, we'll, as always, we'll be sending out our questionnaire and about feedback. So please answer, if you have some time, please give us your opinion, because it helps us with the organizing efforts. For the last time, we had a opinion that all the talks were quite long, so hopefully today it was a bit better. So next time, hopefully you'll answer that everything was okay, at least on the lens side. And also, please join our community on Facebook, which is called Backendisti.cz Comunita, and you can also connect over there. So thanks again, and see you next time.